Here is another problem. I made this one up. So let's just work it out. I have two ping pong balls, and imagine that I get them electrically charged so that they repel. Okay. Imagine also that I could hold one, and this would never really work, but you could imagine that I hold a ping pong ball right here, and the other one is electrostatically repelled, so that it's above that some distance, 2 centimeters. So the question is, how many extra electrons do I need on these ping pong balls in order for them to hover? So let's draw a force diagram for this top ball. I have the ball, I have the gravitational force mg, and then I have the Coulomb force, I'll call it Fc, like that. And if it hovers, then these two have to add up to 0. In the y direction, I can use Newton's second law. F net equals Fc minus mg equals 0. This is in the y direction. So I can write these as a scalar equation, right? So that one's in the positive y direction, that's in the negative y direction. F net as vectors, you add them up as just vectors though. Okay, well that's not too bad. I know the mass of the ping pong ball, I Googled it, 2.7 grams, 2 centimeters apart. I can just put in my value for my expression for the Coulomb force. So let's do that. K, Q1, Q2, they're the same charge, so I'm just going to call it QQ. I'll call this R squared. That's my Coulomb force. It's pushing up. And then I have minus mg equals 0. Let's go ahead. What do we want to solve for? We want to solve for Q. So let's write this as KQ squared over R squared and add that to both sides. So I have KQ squared over new chalk. R squared equals mg. Now I can multiply both sides by r squared, divide by k, and I get q squared equals mg r squared over k, and then I just need to take the square root of both sides. That will give me q. I'm going to start with that q. So let's find the value. Oh, and then let's just put it all in one thing. Right. So then I can write q as n times e. It's a number of electrons times the charge of each electron. And if I do that, I can solve for n. That's what I want. So n is going to be equal to q, but then I need to divide by e. So it's 1 over e times the square root of mg r squared over k. So let's put in our values. N equals 1 over 1.6 times 10 to the negative 19th, sorry about that. Square root of the mass, which is 2.7, 2.7 times 10 to the negative 3. So because I'm using G in newtons per kilogram, I need the mass in kilograms. So 2.7 grams is 2.7 times 10 to the negative 3 kilograms. G is 9.8. R is, again, since I'm using G is 9.8 newtons per kilogram, I need to have the distance in meters. So this is going to be 0.02 meters squared. And then divide that by 9 times 10 to the 9th. Okay, time to put it in the calculator. I'm going to start off with this, 1.6 times 10 to the negative 19th, enter, and then I'm going to take 1 over that. So then that have that number as 1 over. And then I'm going to do all this stuff in here. 2.7 times 10 to the negative 3, 9.8 times 0.02 enter squared times, and then 9 times 10 to the 9th divided by. Now I can take the square root, and then I can multiply. And I get, hopefully a big number, oh it is, 2.14 times 10 to the, I don't know why I didn't put the scientific notation. 2, 4, 6, 8, 10, 11. It's a number, so that's it. Electrons. That one wasn't too bad, right? Not too bad at all. Okay.